Welcome to David Alexander Maths Tuition. This is chapter 11c, magnitude and direction. Okay, so find the exact magnitude of the vector 3i plus 4j. So we know the vector 3i, so this is the I-axis, this is the j-axis. We're going 3 along and 4 up. So 3 along and 4 up. So the vector will start here and finish here. So what we're being asked here is, well, what is the actual size of this line? What is the length of this line? Well, we're just going to use Pythagoras. By the way, these lines here, that is what is used to represent the magnitude of what's between it. So using Pythagoras, that's going to be the square root of 3 squared plus 4 squared, so that is 5. So the vector 3i plus 4j has a magnitude of 5. Find the exact magnitude of the vector minus 7i plus 4j, so that's going to be the square root of minus 7 squared plus 4 squared. Now, to be honest, if it's negative, I know that negative 7 squared is the same as 7 squared, so I tend to just ignore the fact that it's negative when I'm squaring it. So I'll be lazy, type into my calculator 7 squared plus 4 squared, all square rooted. That is root 65. Okay, so we know from the previous examples that the magnitude of the vector 3i plus 4j was 5. 5 units? So if 3i plus 4j is 5 units, then 1 unit, which is the unit vector, is just this divided by 5. So it would be 3i plus 4j all over 5, or you could just write that as 3/5 I plus 4/5 j, or you could write it as 1/5 of 3i plus 4j. Many ways you could write it. You could write it as the column vector, 3/5, 4/5, or you could even write it in decimals, so 0.6, 0.8. So all of these are ways of expressing the unit vector. This vector has a magnitude of 5 units, so just divide it by 5. This second example, the magnitude was the square root of 65. So for the unit vector, it's just this divided by root 65. So it's minus 7i plus 4j over the square root of 65, which you might want to write as 1 over root 65, lots of minus 7i plus 4j.